Assalamualaikum warahmatullah and a very good day. Bismillahirrahmanirrahim. So today the topic of this video is pipe network. Hardy-Cross method. So at the end of the lecture, student should be able to find flow rates in a pipe network using Hardy-Cross method. Okay, let's see. Okay, for this lecture, for complete explanation, please refer to textbook and a handout given in WhatsApp group. Okay, basically, what is Hardy-Cross method? This method is used to determine the flow rates in a pipe network. So pipe network is a network with 3 or more branches. Okay. So iteration method is used to find Q. So we will use Excel for computation. So I hope by now you are already familiar with iteration method. Many models have been developed using Hardy-Cross method. So for example, from this article, this is quite recent. This article was published in 2019. So it shows that Hardy method is still used by many engineers nowadays to compute flow distribution in pipe networks. So you can have a look at this article later. I'll give this article to you. Okay, what to do in this Hardy-Cross method? So step 1, you identify and label the junctions and loops. In step 2, you assume Q based on information given. This is in terms of value and also direction of the Q. In step 3, you calculate head loss. For this head loss, only major loss is considered. So major loss is from friction loss. In step 4, you calculate delta Q. So you stop the iteration when delta Q is negligible. So then you will have final Q. So only 4 steps in Hardy-Cross method. Okay, step 1, let's see. This is to identify and label the junctions and loops. Okay. So you have this problem. Okay, this problem is from the example. So in the textbook. So let's find the loops first. Yeah. So this can be considered as the first loop, and this is the second loop. Okay. So you can label these pipes. Yeah. Okay. So this is considered as A. You name this as A. And then here you name it as B. Okay. So the direction is, this is the entrance, and it will divide it into 2 direction, which is A and B. Okay. Okay. So in the first loop, there will be another pipe here. So you call this pipe as pipe C. Okay, so in this case, you already complete 1 loop. So in the second loop, okay, so when you do this loop, make sure it is in clockwise direction. Okay, so you have the second loop. So you start with this pipe. So you name this pipe as pipe D. And then, so you have another pipe here, goes into this direction, and this is pipe E. Okay, and you also have one last pipe. This is pipe F. Okay. So it really depends on you. You can decide which pipe you want to label using what letters. Okay, so this is the way I label my pipe. Okay. Okay, let's see. After you identify and label the junctions and loop. So what is junctions? So the junctions is, okay, so this is the first junction. The junction means, okay, so when the flow is coming from this direction, so it will divide into two pipes. Okay, so this is what you call as junction. Okay, so okay, this is enough for this part. Let's see the next step. So the next step is assume Q based on information given. So the Q, there are two information. Okay, let's see first how it explained. Okay, at each junction in the network, the sum of the flow into the junction must equal the flow out. Okay, what goes in must equals to what goes out. So let's say if you call this as junction 1, so what is entering into junction 1 must be equals to what is coming out from junction 1. Okay, so in this case, 1.2 must be equal to flow into flowing into in the pipe A plus flow moving in pipe B. So because just now I put this as A and I put this pipe as B. Yeah? Okay. So the flow tends to follow the path of least resistance through the network. Therefore, a pipe having a lower value of K will carry higher flow rate than those having higher values. So this is common sense. Senang cerita macam ni. Dekat laluan mana yang paling tak ada halangan, dekat situlah paling besar Q. So it's common sense, right? So finally, if the flow in a given pipe of a circuit is clockwise, Q and H are positive. If the flow is counterclockwise, Q and H are negative. So just now I drew this as this, right, for loop 1, and this is loop 2, right? So this is clockwise. When it goes following the clockwise, this is positive. But when it goes the opposite of clockwise, then it's negative. Okay, so we move on to, okay, this is just the title. So we move on to this step 2. How do we do this? Okay, step 1. You did already step 1. So just now you identify the loop. So this is loop 1. And we have loop 2, right? And you label this as A, B, and this is C, and this is D, and this is E, and this is F, right? Okay, so the direction that you determine is like this. And then, okay, so the direction is depending on the loop. Okay, so this flows like this. This is to the bottom, downwards, and this moves to this direction. Okay, so now we want to assume Q. Okay, we want to estimate Q. But first of all, in order for you to estimate Q, you must be aware of what are given in the question. For example, this is given 1.2 cubic feet per second is the flow coming to the network. Okay, so we have another one. This is 0.3. The flow coming out from this junction, from this node. We have one more here. Oh, sorry, this is 0.6 coming out from this node. And finally, you have up here given this is 0.3. So whenever you want to assume Q, you have to make sure that you take these what are given into consideration. So I'll see you in the next video and I will explain how to estimate Q. See you.